In my earlier videos, I have already discussed for any transportation problem how to find the basic feasible solution. I discussed three methods: northwest corner rule method, matrix minima, and Vogel's approximation, that is VAM method. I also discussed the optimization technique, that is MODI method. Today I am going to discuss another transportation problem. This is a complete problem and all the categories, all the types are included in this problem, I think. Okay. So I will solve this problem in two steps. First step, I have to find out the basic feasible solution. And finally, MODI is to be applied to find out the optimum solution. Okay. Now, I'm going to discuss the basic feasible solution. First step. In this case, I will apply the VAM method. I have already mentioned that VAM is the best method out of three methods: northwest corner rule, matrix minima, and VAM. That's why I'm going to apply VAM method for finding out the basic feasible solution first, and then I will apply the MODI. Okay, basic feasible solution. I already mentioned in my previous videos that first, before starting to find out the basic feasible solution, you always check it is a balanced problem or not. How you check? The problem is factories A and B and warehouses C, D, E. That means productions are being done in two factories A and B. Say the factory located at Jamshedpur and B the factory located at Kolkata. And these are the marketplace or warehouses where the production units are to be shifted. Factory A has the capacity to produce 300 units. It is producing 300 units. And B factory is producing 500 units. The requirements here, requirements for warehouse C is 300, or you can say the marketplace. Say this is Nepal, and this is Patna, and this is say Siliguri, you can say. And the marketplace B required 300 units, and the marketplace or warehouse, you can say, where the product to be shifted, E, the required unit is 500. And these are the availabilities. Okay. And these are the requirements. Before starting to apply the method for basic feasible solution, you always check that it is a balanced problem. Balanced problem means the requirements and availability are same. If it is not same, then it is called unbalanced problem. Then accordingly, I am going to check it. The availability is 800 units and the requirement is 1100 units. That means I have taken a problem which is not balanced. Then what you will do, that I did not discuss in my previous videos. This is you can say an unbalanced transportation problem. Then how we proceed, that I am going to discuss. First, you have to convert this unbalanced problem to balanced problem first, and only then you should proceed for finding the basic feasible solution. Okay. Again, I am repeating 25, 17, 25. These are the transportation cost. Transportation cost means if you are producing the product in this factory and shifting these godown or warehouses or sales point, per unit transportation cost is 17. In this way, for 18, if you are producing at factory B and you are shifting the warehouses C, the per unit transportation cost is 18. Okay. Now I am going to make it balance. How will make it balance? See, how will make it balance? What you will do, you will add one dummy sources to make it balance. You have to add one dummy sources. You have to add one dummy sources to make it a balanced problem. D is the dummy source. This is 300 and 300 and this is 500. Now you assume the transportation cost for the dummy sources is 0. Why you are taking 0? That means it is assumed, though for theoretical purpose for solving the problem we are adding these dummy sources, but as the cost is 0, that means it is assumed it is not being shifted at all. That's why the transportation cost is 0. And just to make it a balanced problem, we have added these dummy sources. How much we will add? 300. Suppose these dummy sources is producing 300 units, and the production units are remains to the factory itself, not shifting at all. That's why the transportation cost is 0. But only for mathematical purpose we have added this. Now you add that this is 1100, and the availability I have already mentioned, this is the availability, that is also 1100. That means in this way you can convert an unbalanced problem to balanced problem. Here the availability are less, that's why I have added the dummy source. But if the problem is such that the requirement is less, then what you will do? In that case, you will add one dummy warehouses. The difference is in this way you can make the unbalanced problem to balanced problem fast, and then move for finding the basic feasible solution. Okay, this is the dummy, you can say DUMMY, dummy source. Now I am going to show how you will find out the basic feasible solution through VAM method. I have already discussed the VAM method. Again, I am repeating how you will do it. Find out row wise, you find out the lowest cost. The lowest cost for the first row is 7, and the immediate lowest cost, which is 25. That means the difference you note down at the difference. The difference is 70 and 8. The difference is 8. For the second row, the lowest cost is 10 and the immediate lowest cost is 15. The difference is 5. You note down at 5. And for third, 0 and 0, that's why it is 0. Same process you have to do column wise. The lowest cost is 0 and the immediate lowest cost is 15. That's why the difference is 15. Okay. Now for second column, the lowest cost is 0. The lowest cost is 0 and the immediate lowest cost is 10. That's why the difference is 10. And this is the lowest cost is 0, and the immediate lowest cost is 18. That's why the difference is 18. Okay. After completing to find these differences, you check where is the highest difference value. In this case, 15, 10, 18, the highest difference is this 18. As per VAM's method, you have to allocate in this column, and the rule is you have to allocate to the lowest cost unit cell. Lowest cost unit cell is 0. That's why your allocation will be here. Your allocation will be. The allocation process is same as per northwest corner rule or matrix minima method. Already I have discussed in my previous videos. If you have any doubt, then you please check that. I am not going to discuss in detail. Out of these two, select the lowest one, 500 and 300. The lowest one is 300. That's why you will allocate 300. Then what will be the status? This is 0. The entire requirement have been shifted and the requirement is 200. Okay. As you have shifted the full availability for dummy source, that means it is not allowed to allocate further to these cells. There is no scope because 300 has been already shifted. That's why I have noted it by a mark so that mistakenly I should not put any product and units here. Okay. Next step. The same process you have to do. As there is no changes, that's why directly I am writing the differences 5, 0. Just to save the spaces, I am doing on the same matrix. No have no problem, but in exam you can do it step by step for each steps differences. And in this case, the value has been changed. That's why what will be the differences? The lowest is 15. You cannot consider the blocked one. Already done. 15 and 25, that is 10. And in this case, 10 and 17, that is 7. And in this case, 18 and 75, that means 7. So these are the differences, and out of this you have to find out the maximum different values. That is, this is the maximum different values, 10, 7, 7, 0, 5, 8. Now, as per rule of VAM, you have to allocate, you have to put your allocation to the lowest cost. Here the lowest in this column, you have to put in this column, the lowest cost cell is this. Then how much you will put? The units requirement is 300, this is 300, and available is 500. So out of these two, the lowest one you will take 300 and 500, the lowest is 300. That's why you will put here 300. So the balance requirement is 0 and the balance availability is 200. As the full amounts, the required amounts have been fulfilled, have been shifted here, that's why there is no scope to put in this cell. That's why I have blocked it. Continue the process as done earlier. So we have put here, that is this full 0. That means in this case 10 and 70, the difference is 7, and 18 and 75, the difference is 7. and horizontally you will not consider it as it is blocked. 17 and 25, that is 8, 10 and 18, out of 10 and 18, 10. The difference is 8. And where is the highest difference? The highest difference is here. The highest difference is here. Okay? That means you have to allocate, you have to put your allocation in this row. And where you will allocate? The lowest cost cell. That is this one. The lowest cost cell is this. How much you will put? The availability is 200 and the requirement is 300. The lowest one. That means 200. Okay? 200. 0 and this is 100. So as the entire availability have been shifted, that's why there is no scope for shifting them. Only one row is left. That's why you need not to find out again differences. You can put directly also, and if you calculate the differences, no issues. It is same. So how much you will put here? Still to be sent 100 units, and in this case 200 units. As it is a balanced problem, you can see automatically will be matched. First I am putting the 100 units. You can find out the difference or the same thing. 0 and here 200, and the last one is 200. That is in this way. Okay, 200, 0 and 0. That is entire available amounts have been shifted to the warehouses, godowns in this way. And this is the basic feasible solution. Basic feasible solutions means you have to send the product produced in factory A 100 units to the warehouse D and 200 units to the warehouse E. In this way, total 300 have been shifted. For product from factory B, 3 units are to be shifted here and 200 units are shifted here in this way, and 300 units with the availability it remains to the factory. So this is the basic feasible solution. This is the basic feasible solution means it is the starting point for finding the optimum solution. If you calculate the transportation cost, then you will see this is not the lowest one. If you proceed and do further by optimum technique like body, then this transportation cost will be reduced. Now what is the initial transportation cost for initial allocation? You can see transportation cost is 100 into 17 plus 200, 100 into 17 plus 200 into 25 plus 300 into 15, 300 into 15 plus 200 into 10, 200 into 10 plus 10 plus 300 into 0, 300 into 0. And if you calculate this, the total amount will be the total amount will be 1700 plus 25,000 plus 4500 plus 200. That is 0, 0, 2, 7, 14, 5, 5, 10, 11. 1100 rupees, 11,400. Okay, and this is the total transportation cost for basic feasible solution. Now, when you will optimize it, then you will see either the total transportation cost will be at least same or low or minimum from this amount. That means there will be the cost benefit. Okay. Now I am going to show how to apply the model. Okay. In the same table, I am going to use the same table just to save the space only. So you should do it in a separate page. Okay. Now this portion is not required further because I have already find out. I have got the basic feasible solution. This matrix is required. This availability, these are not required for the MODI application. That's why I am erasing this part. And you just note down it. The transportation cost for this allocation is 11,400. So that I will check that after optimization, the cost has been either decreased or at least same. Okay. So I am erasing this portion because that will not required for optimization. Just to use the space, I am erasing it and using the same matrix. But for your purpose in exam, you should do it in a separate page. You note down this matrix to a separate page and then solve it. Okay. Now I'm going to, this is the basic feasible solution. If you want to write it, this is x1 to say x row and 2 column is equal to, these are the basic variables. x1 2 is equal to 100, x1 3 x13 is equal to 200, and this is say x3 3 is equal to 300 in this way. These are the basic allocation, basic variables. Okay, now I am going to apply MODI method for optimize this transportation problem. Application of MODI, modified distribution method, as I've already discussed in my previous videos and showed there how to apply MODI method. Okay. Start. Always before starting the MODI, you must check the number of basic allocations are at least n plus n minus 1. You must check this. If it is not, then it will be a case of degeneracy. You have to do something so that you can proceed. Okay, you can use this also, because now it is not required. Basic allocations I have got. I will use this matrix. N plus n minus 1 number of allocations are equal. These are the allocation. These are the basic allocation. Must be at least n plus n minus 1. What is n? N is the rows. In this 1, 2, 3. 3 rows are here. Now n are columns. 1, 2, 3. 3 columns are there minus 1. That means 5. That means 5 allocations are required to find out, to apply MODI. Okay, you check 1, 2, 3, 4, 5. Hence there is no problem. This is not a case of degeneracy. Okay, now how you will proceed for finding the dual variables. I have already mentioned in my previous video. If you have any doubt, you please check. You have to divide the cost for the basic cells into 2 variables. That is called dual variables. In this, I am writing say UI, that is U1, U2 and U2 and U3, and say these variables are noted by Vj, that is V1, V2 and V3. By forming equations, you can do it like 25, that means U1 plus V3. The equations will be U1 plus V3 is equal to 25. In this way, you will get 1, 2, 3, 4, 5 equations, or you will get 5 equations, but there are 6 variables. 6 variables, 3 plus 3. So to solve it, 6 variables, 1, 2, 3, 4, 5, 6. So you will get, in this way, I am not writing in detail. I will show you the shortcut and direct method to save time. If you want to see how it is done, you please check from the previous video. You will definitely understand it. Just to save time, I am going to do so directly. In exam also, one step you will show it, and after that you will do directly. Okay, here I am doing it directly, just to save time and to save the video space. Okay, so here from you start. You always try to start put, because one variable you have to put forced 0, otherwise you can't solve it, because there are 6 variables, but equation is 5. Equals to, for basic cells you will get 5 equations, and but the variables are 6. That's why you have to put one variables forcefully 0. It is helpful. It will be helpful. You try to allocate 0, but the maximum allocations are available. But in this case, all are same. Here are 2, this is 2, this is 2. If suppose here was an allocation, then I will put 0 here. It will be advantage for me. But in this case, all are same. You can take 85. No problem. Only the value of the variables will change, but automatically it will set. The method is like that. So I am putting, say, U1 is equal to 0. U1 is equal to 0. I am taking this side 0. Then automatically you can write 25. V3 is equal to 25. This is 17, and as this is 17, 10 minus 17 is 7, and 15 minus 7 means 15 minus 7 means 8. The concept is an 18, that is 25 minus 18 minus 7. No, this is the basic. This is the non-basic cell. You have to find the values. So U3 is left, still left 25, and 0 minus 25, that is minus 25. How I have done this? Because the concept is, if you add this, then this you will get this, because you are bifurcating this cost to these dual variables. So with the basic cells only, say 25. 25 means 0 plus 25. If you want to form the equation will be U1 plus V3. U1 plus V3 is equal to 25. So you have already put U1 is equal to 0. Is 0. That means V3 is equal to 25. That's why I have written here V3 is equal to 25. This is equal to V2 is equal to 70. You can check it. Okay, I'm not going to discuss. So with the help of these dual variables, U2 is equal to 7, you have to find out the value of the non-basic cells. How we find out it? That I'm going to show you. And for finding that, it is better I am marking in different color, then it will be better. 0, 0, and sorry, not 0, this is circle. If you have any doubt, then you will check my previous video. I have done it in detail. The circle indicates ui plus vj. You put the value of ui plus vj to the non-basic cells. These are the non-basic cells. Here, basic allocations are not available. These are the basic cells where basic allocations are there. That means you have to find ui plus vj. That means with the help of dual variables, you note down the ui plus vj to this circle. Then what will be the value? This plus this. ui plus vj means this plus this. 25 plus 7, that means 32. 32. 25 plus 7, ui plus vj. Similarly here, 17 minus 25. 17 minus 25. That means we have to add this, and the total will be minus 8. We have to write 8 minus 25. That means minus 17. And the last one, 8 plus 0. That means 8. In this way, you will put, this is actually 2 row, that means u2 plus v3. This is actually u3 plus v3. In this way, all circles you have to complete. And the criteria or index for optimization Z, for finding the optimization, Z is equal to Cij minus ui plus vj, and this must be greater than or equal to 0. If for all the non-basic cells, if Cij minus ui plus vj greater than or equal to 0, then you have reached to the optimum solution. But if there is any negative, that means you have to proceed further to change the basic allocations. If there are more than one place negative, then you have to select the most negative one to proceed further. So this is the criteria by which you can consider the allocation has been based or not, or optimum has been reached or not. So I am marking this Z value with triangle to all the non-basic cells. Triangle, I am putting a triangle, and you have to check whether optimum has been reached or not. Okay, this all the non-basic cells. So in this case, 18 minus 32. So how much it is? 18 minus 14. 0 minus of minus 0 minus of minus 8. That means plus 8. Then in this case, 0 minus of minus 17. That means this is plus 17. And in this case, 25 minus 8. That is plus 17. And you check all the values, net evaluations values. These are the net evaluations. You can say net evaluations means Z is equal to Cij cost. Cij in this case 2 row, third column C 2 3 minus ui plus vj. Ui means u2 plus vj means v3. This calculate the value is minus, not positive. That's why we have not reached to the optimum. You can check by calculating the total transmission cost. You can see that the value is different maybe, but it is not the best one. I have not calculated at this point. I am checking if calculator is available. Okay, that I will show you later. So this indicates you have to proceed further. That means it indicates you should put the allocation here. That will be advantage for you to reduce the transportation cost. You must have to put some allocations here. This indicates, but not here. This is the positive. Positive means no reduction of cost is possible here in these cells. So how you revise this? So I can erase this part again, just to say you have noted already. My video is there. That's why I'm erasing this part in the same table. Actually, no, it is. I'm trying to do it in separate table. Okay. Okay. I'm trying to do it, but it will be better if I take this space also, because otherwise it will be slightly, space may not be adequate. Okay, I'm erasing this part and I'm noting the same matrix to revise and to go on. The 3 by 3 matrix is here. That is 3 by 3. I'm noting here 3 by 3. 1, 2, 3. 1, 2, 3. The cost is 25, 25, 17, 25, 17 and 25. Next 15, 10 and 18 and 0, 0 and 0. Okay, 0 and 0. And the basic allocation was 100, 100. Okay, you have to allocate something here. That process I am doing here, and finally I will write the revised basic feasible solution. As you have to allocate here, suppose how much you will allocate? I am putting here theta, or you can put it here any variable p, q, or whatever you like, comfortable to you. When you will put here, so that you have to put some allocation here to find out that quantity, you put any variable, and to make or to adjust it so that the total available requirement should not change it, you just subtract theta plus theta and minus theta. Try to find out a square to balance it. If you add theta minus theta 0, there is no increase. If you add it, there is no increase in this way. 4 corners you can set it. But if the square is not available, then again it will be possible by serially checking. That I am not going to discuss, not going to show here. Okay. So what will be the value of theta? Theta value will be 200. You take the difference one. If, as in this case, both are same, that's why you put 200 minus theta is equal to 0, because one should be dropped and another it will be added. I have taken a very typical problem. You will see just now. So I am putting the value of theta 200. Then what will be the new basic allocation? For this is C, D and E, and this is A, B and dummy D. Then this value will be, you have taken the value of theta as 200. Then 100 minus 200 means 300. The new allocation will be here 300. Okay, and it will be 0. That means this variable will drop here. There is no allocation because 200 minus 200 is 0. That's why here 0. When it will be 0, you do not to write it. And this is 300. No change in this case. 200, 300, and in this case again it is 0. Again it is 0 because 200 minus 200 is 0. I am not writing anything here, but here it is 200. It is 200. Theta is equal to 200. And lastly, this is 300. 300. Okay. So this is the revised matrix after inserting this variable, because this is not the optimum table, and to make it optimum, you have to put allocations to the net evaluation cell. This is called net evaluation cell. If the net evaluation cell, suppose here is minus 20, then you should not take this. In this place, you will put the allocation. Now again, I am going to apply MODI. For MODI, I have already mentioned that first you have to check that the total number of allocations is equal to m plus n minus 1 is equal to, that the total allocation at least must be 10, and this is equal to 3 row plus 3 column minus 1, that is equal to 5. But fortunately, you see here it is 4 only. That means you cannot proceed further directly. If the allocation, if it is not dropped one variable, then you could proceed further from here. But here you see the number of allocation is 4. Then what you will do? This is the case of degeneracy, as the number of allocations are less than m plus n minus 1. I think it is clear. Then how will you proceed? Then in that case, to modify this problem using this, just to take the space, what you will do? You have to put one artificial variable, artificial value, negligible value to any cell, so that suppose I am putting it here, but I don't know where I will put. I am putting here basic allocation, so not in this specific letter as I have noted here, epsilon here, in this way, so that it should not form any square. But you cannot put epsilon here. What is epsilon? That I will discuss. You put a small negligent quantity to get the total number of allocations m plus n minus 1 in such a way so that it should not form any square. That's why it is not allowed. As if I put here, then it will be a square, so that I cannot put here. Then where you will put? You can put here, because say I am putting here. If you put here, there is no square is being formed. It is allowed. Now I am coming to the point. What is epsilon? Because without the adequate number of allocations, so you cannot proceed further. The number of allocations should be m plus n minus 1, that is at least 5. That's why I have to bring one artificial variable with a small negligent quantity. Suppose the quantity you are shifting, this is in quintal or kg, and this is in milligram. And it is so negligible quantity, ultimately it will not affect your availability and requirements in this way. But for the mathematical purpose, only you have to add it. That is the purpose. Okay. Now we can proceed same way we have done earlier for apply model. Then again find out. I'm doing directly how we'll do. We check it. So I'm putting 0, the variable value, as here is maximum number of allocations. To get the process faster, I'm putting 0 here. And you can put directly 18, 10 and 15, because 15 plus 0 is 15, 10 plus 0 is 0. That's why I'm putting it directly. Okay. Now this is 0, and with the help of basic cell you have to fill up this variable. 0 minus 18 you will do in this way, because if you add this, then you will get this value in this way. That's why if you minus it, then you will get it. So, and one value still left, that means with the help of this basic cell you have to fill up it. So 17 minus 10, 17 minus 10 means 7. This variable is 7. That means if you add this, it will get this 17. So another is left still 25, 20. These are the variables. Okay, completed. This is U1. You can say this is U1. This is U2. This is U3. As decided already. This is V1. This is V2, and this is V3. You can form the equations and then solve it by putting one variable 0. No problem. But in this case, to make it faster, because in exam also you get limited time, you can do it in this way. Now again, you have to find out the UI plus Vj, that is circle, or the non-basic cell. This is circle, this is circle, and this is non-basic cell, this is non-basic cell, and how much you will get. This is UI plus Vj, that is 17 plus 7 plus 18, 25. 25 will be written here. Then here is 15 plus 7, that is 22, and here 10 minus 18 means minus 8, and in this case 15 plus minus 18 is minus 3. In this way you will keep. This is UI plus Vj, and now you have to find out the net evaluations value. That is net evaluations value that I'm going to show you through a triangle. This is the net evaluation value for the non-basic cell. For the non-basic cell, net evaluation triangle, the value is Cij minus Ui plus Vj. Now, and that must be greater than or equal to 0 for optimum, means best allocation. In this case, the total cost will be minimum. Now, check Cij minus Ui plus Vj. That means this minus this. To put the value, that is 0, 25 minus 22, this is plus 3, this is plus 3, 0 minus 8, that is plus 3, 0 minus 8, that is plus 8. And you can check in this case, all the net evaluation values have become either 0 or positive. No negative value has come. If there is again any negative, then you have to further proceed for get a best solution. Okay. Now we can come to the conclusion that we have reached to the optimal solution, and that means you have to shift from this factory to this warehouses 300 units, from this factory to this warehouses 300 units, and this factory to this warehouses 200 units in this way. And it will not shift at all because the transportation cost is 0, and you can check the availability is 300, 500 is satisfied, and the requirement, that is 200 and 300, 500. In this way, you can also verify. And what will be the minimum cost? Minimum cost will be total transportation cost. In this case, 300 into 17, 300 into 17 plus 300 into 17 plus, and it is very negligent quantity. That's why I'm not taking this value. You can say it is 0. And this is 300 plus 15, 300 into 15 plus 200 into 18 plus 200 into 18, and this is 0 plus 300 into 0 is 0. 5100 plus 4500, and this is plus 3600. And what is the total value? 6, 4 5 9 और 45 का 36 200 डबल जीरो 6 पर 11 4 5 9 और 4 8 5 10. But in this case 11,400. Again I have to check the field calculation mistake was there. In that case I have not used it. The basic solution was this. The total cost was 1700 into 17 plus 100 into 17 plus 200 into 200 into 25 plus 125 plus 200 300 into 15 plus 300 into 15 plus 200 into 10 plus 200 into 10 100 into 10, and this is 0. How much is 1700 plus 5000 500 plus 2000. How much it is? 2000. It is 0 0 0 0 0 0. Now 0 5 8 1 8 and 18 7 and 12 oh, sorry, that was not 11,400. You can check it. Okay. The total amount is this. As for my calculation, you can also check it. It remains same. In this table, whatever it would be, that is not changed after doing the process. I am assuming this is correct. Again, I am just checking it. 1700, okay. Then 5000. This is 4500, and this is 2000. And because the allocation was here, you can check it. It was not available that time, and you have to add. And this is 0. 300, that is 0. And if you total make it totally 1500, 1000, 1700, 5000. First again, I am checking just done a mistake or not. 4500, 4500, 2000. Okay. Then 0 5 okay. This is same. That means what is the conclusion? That means the total cost has not been decreased, but at least remains same. This is the definite proof of the minimum cost as per money. Okay, that means your solution will be the allocation will be this. What I have already mentioned. You have to shift from this source to this source in this way. Okay, and the total cost will be definitely minimum 13,200. You cannot reduce after that. This is, you can check it by shifting any quantity from any allocations and balance it, then the cost will be increased. That means this is the best solution after applying the motivator. This is the confirmation test. In this case also the cost is same. That means you can say this allocation is also possible. That means it is a case of multiple solution. As the lowest cost is minimum, but in two ways you can shift the quantity to the destination. That means it is also allowed. From factory A you can shift to the factory D the 100 quantities, and from factory A to E. In this way also you will get the same cost. That's why as a manager or decision maker you can also apply your decision this matrix. Okay, but you can say, sir, then why we are doing this unnecessarily? No, you should have to follow this process, because after doing this you have come to the conclusion, you have been confirmed that this is the lowest cost. If you not done this, then you cannot be sure, you cannot confirm it. That's why this is the confirmation test, you can say. After applying body, and if all the rules are followed, then you can definitely that this is the minimum allocations. Now if you can change it any, then the cost will be increased. But except this, because the cost is same, that's why you can also take this allocation also. In this way, you can find out the optimum solution for any transportation problem. Again, I am repeating in brief what I have done because the problem is to be solved in two steps. First, you have to find out the basic feasible solution and then optimize it. Basic feasible solution is done by three methods: northwest corner rule, the matrix minimum method, and Vogel's approximation method. So as per my consideration, the van is the best method. But you can do the northwest also, matrix minimum also. And generally we have seen, if you have taken the other methods, the later steps generally increase more. Okay. Then how we find the basic feasible solution? First, you will check that it is a balanced problem. It is not balanced, then inserting dummy source or dummy availability, dummy source or dummy requirement, the problem should be balanced. How I have already discussed. And after balancing, then you will find out the basic feasible solution. And after finding the basic feasible solution, you will move for application of MODI. Before application of MODI, you always check the total number of allocations must be n plus n minus 1. M is the row, n is the column, and the total. If it is not, then it is a case of degeneracy. How you have overcome the problem of degeneracy? By inserting epsilon, a negligible quantity, that also I have discussed. And in this again, you will find out the dual variables. You have to find out the dual variables with the help of the basic allocations, considering the cost of that. And finally, you have to find out the net evaluations value and check all the net evaluations. The formula Cij minus Cy plus Bj for all non-basic cells greater than or equal to 0. Then you can say this is the best. This is all about the optimization. I will solve in my other video another problem, which will be the maximization problem. In that case, I have already mentioned, instead of cost, in that case, suppose you are producing the product in this factory and you are shifting this sales point, and per unit profit is this. Instead of cost, the profit figure is given. If it is the profit figure, they definitely will be interested to maximize the profit. That's why it will be a maximization with the problem with the help of transportation problem. That will be solved. How you will do it, that we will discuss later on in a separate video. Okay, thank you very much. I think it will be helpful for you. If you have any question, you please write to the comment box. I will definitely reply it. Thank you.